primarily focus on cross-sectional studies. The objective of this session is probably primarily to understand the steps of cross-sectional study design, understand what prevalence ratio is and how to interpret that, as well as what are the advantages and limitations of cross-sectional studies. Now we get back to this epidemiological study flowchart that we discuss almost every session. So we already know that we have two types of studies. That is one, those are observational, non-experimental studies. On the other hand, we have experimental interventional studies. When we're talking about observational studies, we have two types. One is like population-based, while the other is individual-based. As we've previously discussed, population-based, good examples would be the NFHS survey, as well as ecological studies, which consider population as units. But today we will be primarily focusing on analytical types of studies under individual-based. The other types of studies that exist are also case report and case series. Talking about analytic types of studies, we have cross-sectional studies, case control studies, as well as cohort studies under this heading. We spoke about case control studies in the previous session, where we said that how it consists of two groups, like a control, and one would be the cases, and then we start from disease to exposure. It is more so a retrospective type of a study design. Then we also spoke about cohort study designs, which are like follow-up studies, where we start from the exposure and follow up until the disease formation. Today, we will be focusing on cross-sectional study designs, which are also called prevalence-based study designs. And this is called because it is more so like a snapshot of the population. When we're talking about the big pyramid, on the base, we have the less important studies, even so less important, but still add some value, that is expert opinions, animal research, case series, and case report. Then we have case control studies and cross-sectional studies. Superior to those, we have cohort studies. Superior to them, then we have the RCTs. And finally, on the top of the pyramid, as we've always discussed, is systematic reviews and meta-analyses. Now, a good question here, as we can also see in the pyramid, that it's like case control studies versus cross-sectional. Like, what do you all think is more superior? Shri, would you like to just upload the poll? And I would request all the participants to just go into the activity section of this meeting, and you all can just put in your opinion, whether you all think it's a case control study design or a cross-sectional studies design that is more superior. I'll give you all a minute to do that. And it's completely fine if y'all can choose either. I would encourage all participants to just choose any answer, and that's fine. Right now, we have like equal votes for both. Wow, we have equal votes for both. So in the study pyramid, cross-sectional studies are considered a little inferior as compared to case control. So according to this, RCTs are considered the best. Then we have cohort, then we have case control, and then finally cross-sectional studies. As I mentioned, that cross-sectional studies are nothing but like a snapshot of the population, because it gives us an idea of like exposure and disease in real time. And as I mentioned earlier, it is an observational study design. So this diagram very nicely depicts on how we're trying to find a relationship between exposure and disease status. So both of this, we can see that both the exposure and disease are studied at the same time, and they exist at that particular time when the study starts. This is inverse to the other study designs that we've discussed prior. When we talk about case control studies, it was more like a retrospective, where in time we had two groups, that was disease and non-disease, and then we went backward in the past and we found out regarding the exposure and then found a relationship between them. Whereas in cohort studies, what we did is in that particular time, we had two groups with exposure versus non-exposure. And then in a period of time, we followed them and looked at outcomes. So this one does exposure and disease at that particular point. And that's the reason it's also called a cross-section or a snapshot of the population. And now the question arises, why would we want to do such a cross-sectional study? This would be done primarily to assess the burden of disease in a population and assess the need of health services. Excuse me. It also helps us to compare the prevalence of disease in different populations. At the same time, now, if we're able to find the prevalence of diseases in different populations, then we can actually look at trends in the disease prevalence or severity over a period of time. Again, this picture very nicely depicts how cross-sectional, case control, and prospective cohort studies are different from each other. I would just reiterate this because I feel like this is a very important base to understand very well. So I'd just like to reiterate where a cross-sectional study looks at something in the present, where both exposure and disease are available at the same time. A case control study starts from diseases and looks in the past for exposure, whereas a cohort starts with exposed versus non-exposed groups and looks in the future for development of the disease. Now, coming to the types of cross-sectional study design. So we have two types of cross-sectional study designs. One is a descriptive one, while the other is an analytical type. Talking about descriptive types of cross-sectional studies. So in a descriptive type of a cross-sectional study, it is primarily used to calculate the prevalence of a particular disease or a health-related entity. And in this particular type, we're not doing a test of any association of exposure and disease, and the analysis is very simple. We're only looking at prevalence of a disease, and therefore it is also known as a prevalence study. Now we have a very good example to understand the steps of a descriptive cross-sectional study design and how prevalence is actually calculated. So to take an example, for example, we need to calculate the prevalence of ovarian cancer in females in Mumbai by a descriptive cross-sectional study. So what would be the first step? It's obvious. First, we're going to choose population. So we will choose a sample size from a population that meets inclusion and exclusion criteria. After that, suppose we choose about 1,000 females that match inclusion and exclusion criteria, and we make sure that we're choosing them randomly. Then the second step would be testing how many actually developed ovarian cancer. In this particular case, we found that 80 women were found to have ovarian cancer. So the next step now would be calculating prevalence. So the prevalence of disease is calculated by the disease population upon the total population into 100. So in this particular case scenario, we know that our disease population is 80 women who were found to have ovarian cancer. So the numerator would be 80. The total population that we selected for this study were about 1,000 females. So our total population would be 1,000. And then we multiply it into 100 and we get the prevalence percentage. In this particular case, 8%. To further understand this and just get this concept nailed down, let's practice an example and understand this. So, for example, now we are looking at prevalence of gestational diabetes mellitus in pregnant females in Mumbai by a descriptive cross-sectional study design. We chose a sample size and we chose a amount of probably 100 women, pregnant women, and they were screened for GDM. And the number of women that were actually diagnosed were found to be 50. I would like everyone to just put it in the chat box, or feel free to unmute yourself and just tell us what do you think is the prevalence here? And no, I don't expect you all to calculate. Oh, okay, we have people who've actually calculated. I was just going to say that maybe numerator upon denominator, but wonderful, you guys have got it. So it is 10%. So again, disease population upon the total population. Wonderful. Thank you very much for proactively responding and like calculating it so fast. So it is 50 upon 500 because we have 50 women who were diagnosed with GTM upon the total population that was included for this study was 500 into 100, that is about 10%. Now, initially, we spoke about what descriptive cross-sectional studies are. Now we talk about what analytical cross-sectional studies are. So an analytical investigation in which subjects are sampled at a fixed period and then association is like made between the risk factor and the disease. So that is what analytical studies are, where we are actually establishing a relationship between the risk factor and the disease development. So as I mentioned, we're establishing an association between exposure and disease. At the same time, we also are measuring the prevalence of the disease and the exposure of the risk factor like at the same time. Unlike descriptive studies where we were only looking at the prevalence of the disease in the population. Now, this is just a quick summary of everything we spoke about so far. So here, in this particular study design, what we're doing, a sample is drawn, and then both outcome and the disease, like the exposure, are obtained, and we're trying to find an association between the two. On the right-hand side, we can also see how case control studies work, where we have diseases in the present because we start with two groups, disease versus non-disease, and look at exposure in the past. And then for cross-sectional studies, as I mentioned, both are in the present. Finally, for cohort, we start with exposure and follow up with patients until they form the disease. This is a very good pictorial representation of like the differences between the three. Now talking about the steps of analytical cross-sectional study design. So before we actually get into the steps, let's talk about research question and just revise that concept again. So in this particular thing, we have the research question as, is OCT associated with ovarian cyst development? So when we start any study, we first try to establish the null hypotheses and the alternate hypotheses. So null hypotheses is nothing but usually opposite to what we expect the outcome to be. An alternate hypothesis is something that we're expecting the outcome to be. Usually in cases, we reject the null hypotheses and therefore automatically accept the alternate hypotheses at the end of any study. And it can be vice versa as well, but this is just the common way it's always followed. So in this particular example, the null hypothesis would be that OCT is not associated with ovarian cyst. It is something opposite to what we're expecting. And the alternate hypothesis is that OCT is associated with ovarian cyst. Now, looking at like the major broad steps, like what exactly would be the major steps in this particular cross-sectional study design? So first, we would obviously recruit patients based on inclusion and exclusion criteria. Then we would study the exposure and outcome at the same time. And finally, we would present that relationship in statistical terms. In this particular case, for cross-sectional studies, we would like to use prevalence ratio. We've discussed this before, that for cohort studies, we usually use a relative risk, while for case control studies, we use odds ratio. And in the case of cross-sectional study designs, we like to use prevalence ratio. Further, I would explain more on how this is actually calculated. Now talking about the step one of this. As we mentioned earlier, it is the selection of the study population. So usually we pick up this study population from the general population pool by random selection to meet our inclusion criteria. For this particular example, we selected about 200 females. As I've already mentioned before, but I'd just like to re-emphasize this point, that in a cross-sectional study, neither the outcome nor the exposure are fixed before the start of the study. So we look at both of these at the start of the study. Unlike cohort study, where the exposure is fixed at the beginning, whereas in case control studies, where outcome is fixed in the beginning, A cross-sectional study has these two seen at the same time in the beginning of the study, and they're not fixed before the start of the study. The next step is that we take a look at the prevalence of exposure. So we start taking a history of OCP use in our particular example. So here we took a history of OCP use for patients who at least were using OCP for more than 3 years. And from all the 200 people that were asked this question, we found out that 120 were OCP users, while 80 were non-OCP users. Now, at the same time, the step 3 would be like measurement of the prevalence of outcome. So we try to establish how many patients actually, or how many subjects actually developed ovarian cyst. And in this study, hypothetically, we found that 30 women were found to have ovarian cysts. So now the fourth step is prevalence calculation, as like we learned in the earlier example in the descriptive type of cross-sectional study. So now I would just reiterate the numbers for you guys. So we found that 30 women found ovarian cyst, 120 were OCP users, 80 were non-OCP users, and we had a total population of 200 participants. What do you all think was the prevalence of ovarian cyst in this particular population? And it's fine if you all don't give me the actual percentage. Okay, we have the percentage. You guys are too fast. Wonderful. You all are right. It's 15%. So again, this goes the same way. We take the disease population divided by the total population multiplied by 100. So that would be like 30 upon 200 into 100, which is 15%. Now we talk about the next step. That is the interpretation of the prevalence we found. So that is like 15 out of every 100 females were found to have ovarian cyst in the given population. So this would be the interpretation. Now we're going to the next step of this study, finding the prevalence ratio. And what is a prevalence ratio? It helps us statistically find out if there is an association between the exposure and the disease. And this becomes really, really important to find this out, and we're able to present it in a way where we can actually find the amount of association, because this ratio gives us a numerical value of how strongly the exposure and the disease is related. So we can do this with this particular table that we form. So we can form two columns, that is disease versus non-disease participants. And on the rows, we have exposure history, those who had an exposure history, for example, in this particular case, OCP users versus non-OCP users. And then we hypothetically name them A, B, C, and D. So A would be those who had an exposure and developed the disease. B would be those who had an exposure but developed no disease. C would have an exposure and develop the disease, while D is the one that did not have the exposure and did not develop disease. What is prevalence ratio? So it is the prevalence of disease in those who were exposed upon the prevalence of disease in those who were not exposed. Okay. Now first, let's try to break down the denominator. It is a prevalence of the disease in those who were exposed. So how would we do that? It would be A divided by A plus B. So it would be the number of people who had an exposure and developed the disease, that is A, upon those who had the exposure, but like the total population who had the exposure. So that would be A plus B. Now, similarly, for prevalence of disease in the non-exposed participants, we would look at C, that is those who developed the disease in non-exposure, upon the total people who were there in the non-exposed group, C plus D. And then that is a prevalence ratio, that is A upon A plus B divided by C upon C plus D. I understand that this is like a little complicated, or it just can be very overwhelming when heard for the first time. If you guys have any doubts or just want me to repeat this concept again, I'm happy to do that. So please let me know either on the chat box, or you can like unmute yourself and let me know. Would you like me to just repeat this concept again? I'll wait for a minute. Okay, it seems that everyone has been able to understand this really well. I'm really happy. Now let's just practice an example and just see if we're able to apply what we've learned. So again, we're following the same example that we started. So in this particular case, we found that there were 25 OCP users that developed ovarian cyst, while there were 95 OCP users that did not. At the same time, for non-OCP users, 5 women developed ovarian cyst, while 75 did not. Would you all like to tell me the prevalence of ovarian cyst in OCP users? You can just put it in the chat box of numerator versus like upon the denominator. So the prevalence of ovarian cyst in OCP users. Wonderful. It's wonderful to see you guys calculating so fast. Yes, so as y'all have written it on the chat box, it's 25 upon 25 plus 95. So that is the prevalence of OCP, of ovarian cyst in OCP users. Now let's talk about the prevalence of ovarian cyst in non-OCP users. What would that be? It's very similar to the one that we calculated earlier. And feel free to just put in the numerator and denominator right across and not calculate the values. Yes. It's so nice to see such active participation. So yes, it is 5 upon 70 of 75 plus 5. So now when we talk about the prevalence ratio of this, so it would be ovarian cyst formation in OCP, prevalence of ovarian cyst formation in OCP users versus ovarian cyst formation in non-OCP users. And that would be like a ratio. So it would be the ratio of what you guys have like put on the chat box. And I will just, this is just another slide that depicts that. So it would be 25 upon 120 into 100 and 5 upon 80 into 100. And then just the ratio of the two. Now, in this case, after calculation, it was found that in this particular example, 3.3 was found to be the ratio. Now let's talk about interpretation. Shreep, can you put on the second poll that for the interpretation so that everyone can just attempt that? And just to reiterate, y'all can go to the activity section and there y'all can see a poll section where you can respond to this question. What do you all think is the interpretation for this particular question? Does it show that there is a positive relationship between the two, that is OCP usage and ovarian cyst formation, or do you think there's a negative relationship, or do you think there is no relationship? And I'll just give you all a couple minutes and feel free to just choose anything, either or. It's so nice to see you all actively participating. We'll wait for a couple more seconds. Great. So most of you all have chosen positive relationship, which is right. And a 3.3 value signifies that ovarian cyst formation is 3.3 times more prevalent in OCP users as compared to non-OCP users, and therefore, obviously, it's giving us an estimate of positive association. However, I would like to stress this point that this evidence of relationship between OCP usage and ovarian cyst formation is not really strong as compared to like a case control study or a cohort study, since we're looking at both the disease and the exposure at that particular period of time when this is being studied. So there is not a lot of information that is available, due to which this association, even though it does suggest some association, it's not the most accurate one. Now let's just talk about interpretation of cross-sectional study designs. So when we talk about a prevalence ratio of more than 1, like in our particular example, it just shows that the prevalence rate among the exposed group is much greater, as compared to the prevalence rate among the non-exposed group, and therefore signifying a positive association. When we talk about a prevalence ratio of 1, that prevalence rate among the exposed group is very similar to the non-exposed group, like clearly indicating that there is no relationship between the two. Finally, we have a prevalence ratio of less than 1, where the prevalence rate among the exposed group is much lower as compared to that of the non-exposed group, and that shows that there is a negative association. Before we move forward with the next concept, do you guys have any doubts, or would you all like me to reiterate any section that was not very clear to you guys? It can be anything, the interpretation part, the analysis part, or any questions that I can answer at this point. Okay, great. Yes.
Sorry, Zainab. I think Deepika has a question. Deepika, go ahead.
Thank you. Yes, just I wanted to ask that there was this section where you were explaining the specific types of ratio for different types of study. If you could repeat that once again.
Sure. Okay. So for this, the one that we're talking today is cross-sectional study design. And here we look at a prevalence ratio, as we discussed in this particular session. When we talk about cohort studies, we look at relative risk. And that is something that, just a minute, I think there was some, okay. That is something that we will be discussing in the next section in more detail on how exactly relative risk is calculated. But just to know broadly that relative risk is the statistical analysis or the tool to find a relationship between disease and exposure in a cohort study. Now, finally, talking about case control studies. As we spoke in the previous section, it is calculated with odds ratio, which is more so like a cross-product thing. That's the method that was used. Does this answer your question, Deepika?
Yes, thank you so much.
Sure.
Hi, could you please repeat the difference between descriptive and analytical cross-sectional studies?
Sure. So a descriptive cross-sectional study is nothing but just looking at the prevalence of disease in the population. That's it. We're not looking at the association of the prevalence of disease and the exposure. And when we start looking at the association, then it becomes an analytical type of cross-sectional study. Does this answer your question?
Yes, thank you.
Sure. Are there any other questions at this point? Okay, wonderful. Now talking about prevalence odds ratio. As we already discussed earlier, that odds ratio was something that was used to calculate an association in a case control type of study. But when we apply the same thing to a cross-sectional study, then it forms something, we can calculate something like a prevalence odds ratio. But one has to keep in mind that the prevalence odds ratio that is calculated will be much weaker as compared to odds ratio, as we know that a case control study is considered superior than a cross-sectional study. And just to reiterate this point, that the odds ratio calculated in a cross-sectional study would be a prevalence odds ratio. Shri, can you like upload the final poll? Thank you. So a cross-sectional study can be conducted as a baseline for which type of study? As we already know that cross-sectional study designs are not the best of study designs when we compare it to a cohort or many other study designs. So what can it be used as a baseline for? Which type of study design? And I will be discussing this ahead, so just feel free to guess whatever you all think can be the answer. I'll give you all a couple minutes here. Thank you all so much for participating in this poll. I see that a lot of you guys have chosen case control study design, but it is found out that a cohort study design can be used, a cross-sectional study design can be used as a baseline for a cohort type of study design. Because a case control study design starts with disease. So we already have like two populations, like a disease versus non-disease, whereas in a cohort, we'll be following that patient for a period of time. So therefore, cross-sectional study designs serve as a very good baseline for cohort studies. Now we come to the next session of this particular thing where we talk about the advantages of I hope I'm audible. I'm sorry, I just had like an electricity cut at my place. Shri, please, can you just confirm if I'm audible?
Yeah, you're audible.
Wonderful. Okay. So talking about the advantages of a cross-sectional study design. So it's pretty fast, primarily being because at the same time, we were like comparing both the disease and the exposure. We're not following up patients. So therefore, it's really fast. At the same time, it's very inexpensive. As it's very evident, since it's an observational study, it's non-invasive, and there are not a lot of ethical issues because it's non-invasive. So these are some points that are advantages. At the same time, as I said, that it can be used as like a baseline study or more like a pilot study before we actually go ahead and do a cohort study. So these are like some of the primary advantages of a cross-sectional study design. Now, coming to the limitations of cross-sectional study design, there are a number of limitations with this. One of them being that the measurement of both exposure and outcome is kind of occurring at the same time. So it is very difficult to derive an absolute causal relationship. And this kind of study design is also prone to a lot of biases. One of the most important bias that can be involved here is the antecedent consequent bias, which occurs in a cross-sectional study design where it cannot be determined if the exposure will actually occur before the disease. And because both of them are ascertained and looked at the same time. So this particular bias occurs in a cross-sectional study design. Thank you. So we're done quite early today. We've been through the entire section of cross-sectional study design. Now I would like to open the floor to all the participants to let us know if you all have any doubts or any questions at this point. Are there anything that we can is there anything that I can reiterate, re-explain, or just make something much easier for you guys to understand? Or do you all have any questions for me? Okay.
Hi, this is Ovia here. Can I ask a quick question?
Sure.
Does a prevalence or odds ratio work the same way as our general odds ratio calculation, where we like cross multiply the products? Is that the basic
Sure.
formula?
Yes, the
And
formula
does
is,
it?
yes,
Sorry,
I'm
you were saying
sorry.
something?
I'm sorry. Yeah, you can continue your question and then I'll respond to that. I'm sorry.
Yeah. And does the interpretation also remain the same? As in, if it's greater than one, we assume there is a strong relationship between the two. If it's equal to one, we like there's no significant relationship, and if it's less than one, it's almost protective. Does that hold true too?
Yes, that holds true too. The method is just the same. The cross product method that we studied in the last session, it's going to be the same. The only thing with this is that its value is a little lesser as compared to an odds ratio, as well as a cross-sectional study, or as well as a case control study design in general. But the rules and the interpretation remain the same. Does that answer
All
your
right.
question?
Thank you. Yes, it does. Yes, it does.
Wonderful. In the meantime, I would also request all of you to just like switch on your cameras so that we can take a little screenshot. At the same time, please feel free to ask any questions, anything that you all have. Also, Shri, I would also request you to please post the post-event questionnaire. Okay, sure. Yeah, we have a question here that someone scored a little less than 70% in the last session's questions. Sure. So the way ahead for that is that our team will reach out to you with the questionnaire again, and you can refill it. And if this time you are able to pass the 70% benchmark, then we're happy to provide a certificate for that. So now that you've mentioned, Shri will be just posting the post-event questionnaire. And just to reiterate that the criteria for certification is attending this live event. Apart from that, also getting at least 70%. But at the same time, we also give another chance in case if you haven't been able to score that. So are there any other questions? Thank you so much, Uvia, for switching on your camera. I would request others to switch on their cameras too so that we can take a screenshot. Thank you, Dr. Deepika. I think this is also a good time for Shri and Porus. If you all have anything else to add on or anything else that you would like to talk to everyone about. Shri, would you like to say something?
Thank you so much. I hope you guys enjoyed today's session. And if you have any doubts, please feel free to reach out.
Sure. Yes.
Hi. One more question. Like, based on your practice, on everyday practice, especially in a hospital situation, could you possibly give examples of when exactly do you end up choosing the different types of studies we've studied so far?
Okay. It also, I think it very practically depends on the resources available, because as mentioned, a cohort study just needs more resources in terms of like following up patients. Sometimes in certain settings, one does not have the resources to do that. So then one would like look at either a cross-sectional study or a case control study. But with case control studies, what becomes very important is having data prior data available. Some of our hospitals don't have those records. Then in those cases, then we are forced to like look at a cross-sectional study and then maybe get more resources and convert it into a cohort study. But I think it mostly depends on like how much time is available for conducting that study, and second, what are the resources available. I would request everyone to fill the post-event questionnaire and feel free to reach out to us on our official email address, research.simsogyn@gmail.com, in case of any questions. And very soon we will be sharing the recorded session and the PPT for your reference. Thank you.